Hatte ich eigentlich? Ja? Okay. Okay, hello everybody. We're about to start. I'm Marco, I'm from Nuremberg, but I actually climbed the mountain and entered a dark castle to come here to give you this workshop. And I'm happy that there are so many people here. And first of all, thank you for being here, for your interest in this workshop. And the first thing I would like you to do is give yourself a big applause so you still have this time and this energy to enter this workshop. So a big applause to you. Before we even start, I have a first assignment to you. We have these walls there in each corner of the room. And each wall shows the same diagram. We have JavaScript there, and we have TDD, which means test-driven development, in the corner. And I would like every one of you to make some self-evaluation, to think about what would you say are your JavaScript skills and what are your skills in test-driven development. You will come forward, take one of these points, one of these dots, and place them on the wall. So if you never have heard about JavaScript and TDD, you think TDD is something you can eat, then you place your dot there at the 0, 0 point. If you like the world expert in JavaScript and have invented TDD, maybe it's more like in this place and everything in between. So find your place where you think you would self-evaluate your TDD and JavaScript skills. Find the wall that is nearest to you. We have 4 of them. Just find the one that's in the corner where you sit, which is convenient for you to reach. Get one of these dots and place it where you think you would self-evaluate your skills in TDD and JavaScript. Okay, so go. Everybody, stand up, find the wall, place your dot. Bitte? Test-driven development. TDD means test-driven development. Kannst du mir noch mal helfen? Dann noch mal kurz.
Sofort gerade raus.
Ja. Okay, so thank you everybody. If we look at these charts, it seems like there's a lot of JavaScript know-how already there. So this is a great opportunity to you to learn from each other, not only from me. I think there's a lot of JavaScript know-how there in the room, so you can also learn from your fellow developers everywhere around you. And this is what this workshop is all about, learning more about JavaScript and test-driven development. First of you, who knows this book? Who knows it? It's a very famous book in the JavaScript community. It's about the good parts in JavaScript. You know, JavaScript has its quirks. Maybe you don't know language quirks as a PHP developer, but we have them in JavaScript. And there is also this picture, which is very well known. You might have seen it. So, yeah, these are the good parts, and there's some comparison to the whole body of JavaScript knowledge. But that's just like your opinion, man. You can have different opinion about this. And I think JavaScript has a lot of great parts. And honestly, it got a lot better with ECMAScript 6. ECMAScript 6 improved the language a lot. And today we will take a look at some of the new features and also some of the old features and get an idea how we can use JavaScript in a modern environment. A question I've been asked a lot is, can I use ECMAScript 6 today? Is it ready? Can I use it in a browser? And there is this very well-known chart. It's from Kangax, and it shows the current state where how many features are implemented in which browser. And if you take a closer look at it, I'm not sure if you can read it from back there. These are the modern browsers like Edge and Firefox and Chrome, and all of them have like 80–90% of feature coverage. So yes, you can use it in production, you can use it in the browser. The only exception, if you are in the unfortunate situation that you still have to port Internet Explorer 11, Internet Explorer 11 has only 11% coverage, so you can't use it there. But if you really need to support Internet Explorer 11, which I hope you don't, but if you really need to support it, there are tools like Babel or Traceur, which you can use to transpile your modern ECMAScript 6 code back to ECMAScript 5, and then it still runs in Internet Explorer 11 or even older browsers. And you can use the new features. It compiles backward, and then you can use it. And if you look at Babel, it has like 70%, and the 30% that are missing. It's very likely you won't see that ever in your life as a developer, because these are more the esoteric features you won't use anyhow. So for this workshop, we have some rules, which are very simple rules. First of all, today is not shipping day. There's no need to get anything done. This workshop is all about learning and trying new experiences, finding something about language, about test-driven development, about new methods, about new ideas. You don't need to ship anything. So don't try to get the current problem we will try out. Don't try to get it done. Have no pressure. Just feel safe, try stuff out, take your time. And yeah, that's the to-do list for today. You need nothing to get done. After each sessions, we will do several sessions, hopefully 3, if we will make it in time. After every session, we will delete the code. That sounds a little bit strange at first, but the idea is, if you delete your code, you are free to try whatever you like. There's no need to show it to your boss or somebody else, so feel free to try crazy things just for the opportunity of learning them. And we will start from scratch in every session. So you can try a different approach, new things. other ways to code to do some JavaScript. Also important, we will work in pairs. We will find a pair. I introduce it when the time is there. This is a possibility to you to learn from someone else. So maybe you find a pairing partner who knows already a little bit about JavaScript or have done TDD before. So this is a great way to look at different approaches. And we will do test-driven the whole time. Yeah, if you look at the charts, I see maybe some people are fairly new to test-driven development. Therefore, I will give you an introduction how test-driven development works. If you've never done before, I invite you to just try it out. It's much simpler than it sounds from the books or whatever we might have heard. Just try it out. It feels quite naturally. The idea of test-driven development is that you always start with a test, with a failing test, which means red. If you have a failing test, you have a way to describe your interface, to see how the code should look from the outside. And then you can code against this interface and make your test green. Starting with a red test is also a proof that your test actually tests something. If you have a green test, it could be a bug in the test or something like that, and it could be green the whole time. But if it started red, you know the test tests something. And then you do the implementation, you write a production code, and then the test gets green. And so you know you have a test that is actually working. When you are on green, you can do refactorings. You can change your code, improve it, make it better. And you always have your test that tells you you broke something. So you can feel free to improve something without fearing to make anything worse. And I will give you an example. There's a quite famous kata. It's called the string calculator kata. It's from Roy Orcherouth. And the idea is very simple. Our task is to sum three numbers. Let's say you have 1, 2, and 3 inside a string separated by comma, and we want to write a small program that adds these numbers together so we get the result of 6. And I will just show you how to do it in practice with JavaScript test-driven. Okay. First of all, there's a very easy way to try it out. This is a tool that is called TDDbin.com, and it's just a programming environment for doing katas or exercises, not for doing real production code, but it's very easy to try something out. You don't have to install anything. We can just start coding, and you have a test runner that tells you if your tests are red or green. And it also has these example tests, these principles or code you can just take a look at to see how the syntax of it should look like and how do you use the assertions and stuff like that. Okay, let's get started. We don't need the examples, so I just keep one of it. And what we want to describe is the string calculator. So I start with describing string calc, could be a function. And what could be possibly the simplest thing we could test? A very simple test would be to start with an empty string. So we put an empty string in it, and we expect the sum of an empty string, but should it be some idea? 0. Okay, so let's say string calc, it should return 0 for an empty string. Yes? Sorry? Oh, okay, the font size, yes. Oops. Like this? we expect 0, and we will use the function string calc, which we didn't have coded yet, and we put in an empty string. And if we save, you will see there's a failing test. Should return 0 for an empty string. It's failing, of course. I will scroll a little bit in there. String calc is not defined, is the error message. Obviously, we haven't done it yet. So we should build our string calc function first. I will do it in modern JavaScript syntax. It just looks like this. This means we have a function there. A function is, you can see that there's a function because of this arrow, which returns 0, currently gets nothing. And we save this function here in a variable, or better said, in a constant, which is called string calc. And then we can try it out, and the test becomes green. So it just works. You need maybe some time to get used to the syntax if it looks a little bit unfamiliar, unusual to you. But you could also do it with all JavaScript syntax. It just works. Okay. What else? We can now go to the next test and do something like it should return the value of a single number. Oh, I need to decrease the font size a little bit, otherwise you won't get everything on screen. Is it still readable from there? Back there, yeah? Okay. Okay. Now we do something like assert equal. And we need to put a value in there, let's say a value of 3, and then we expect just the 3 to come back. Okay, let's see. Oh, I get a transpiler error. Yet, now it's better. And it says something like we expect 3, but we get 0, which is obviously because we don't have a real implementation now. We just faked it. So now we need to provide a better implementation. One way to do it, we put the string in there and call parseInt on the string. Oops. Yeah, something like that. Now we can even remove the brackets. They are no longer needed. Okay. But we still get an error. If we take a look at the resulting messages, you will see that the second test is actually fulfilled. It works for the case of 3. But what broke? The first case, the case of 0, broke. Because parseInt doesn't return 0 for the empty string, it returns not a number. So we have to fix our implementation. Let's do this. We need several lines of code now, therefore I need brackets. So we still return the string in the case we have anything but an empty string. But now we have to test for the special case of an empty string. And we could do something like if the string.length equals 0. If this is the case, if the string has a length of 0, it's the empty string. And in the case it is the empty string, what should we do? We just return 0. Length, yes. Okay, and it works. Hooray, we are on green. What can we do when we are on green? Yay, we can celebrate. That's a good idea. But that's not what I had in mind. We could also improve our code. We are in green, so we can refactor now. We can improve our code, and if we do something wrong, the test will tell us. They will become instantly red. We like to try to stay on green. So there's another function in JavaScript, which is very similar to parseInt, which does exactly what we need to. It's called number. And what it does is, it converts to a number. But for an empty string, it returns 0. So this works, and now I can remove the special case, and it still works. That's one of the opportunity that test-driven development gives me. If I'm on green, I can just try it out, and if it works, the test will tell me. Okay, what else? We need another test. And the last test should return the value of multiple numbers. It should return the value of multiple numbers. Okay, and now we need an example like 1, 2, 3, and we want to get the result, the 6 back, which is the sum of all these numbers from the string. Okay, now we have a little bit more work to do. What we get in is the string. What we can, we need to see the failing test first. So you now see the first 2 tests are green, but the third one, the new one, is red. That's the starting point we want to have for this new implementation. So we actually see when it works. Okay, first thing, we split the string. There's a function called split, and we split by comma. So now we have several parts. I can save them to a variable. Let's say let parts. This is also new in ECMAScript 6. It's like the old var, but the old var is the new let. And they changed a little bit more than just the name. It had a better scoping. If you use var, var is function scoped, let is locally scoped. It's just there where you use them. If they are inside a loop or an if, it's just available there. It don't bleeds out of the scope, so it's better than using var. Just kill var from your code. You won't need it anymore. Okay, let's use let, and now we have parts of the string, and we need a for loop to go through these parts. Something like let e is 0 until e is smaller than parts dot length. And inside the loop, we will take each part, parts I, and put it through number. And we can save the result. We can add the result somewhere. So let's have a result variable, which starts with 0. And we just add it up like result, add number to the result. And then we need to return the result. Yeah, that's it. It works. So that's the principle. We can improve on that, of course. We can do now some refactoring because we are green. This isn't perfect code. There's something I really don't like with this code. What we do here is we have several different concepts which we intermix. One concept is the concept of summing up numbers. We have several numbers and we build the sum of them. Another concept is converting string parts to numbers. These are completely different things, but we do it all together in the same loop. And that's just maybe not the best maintainable code. So what I would like to do is build a sum function which I can use, which I can just take out from these. Okay, how does this work? First of all, I need a test for that, obviously. No code without a test. And we describe a new function which will be called sum. And this function should sum up some numbers. Something like that. Okay, so we can say assert. I can just copy this test and remove the string part. Okay, it's the sum of. It should take an array with several numbers in it and just sum it up. Okay, of course, we haven't written the function yet, so let's write it. Sum takes an array of numbers and what it does is almost this thing. With one exception, we don't convert to number because we already get numbers. So, okay, we get an array of numbers. Of course, I have to use this there. There are no longer parts. There are the array of numbers. And okay, sum is green. Now we can use the sum function. And there is where it starts to get interesting. In modern JavaScript, we have a function that is called map. Who of you have heard of map? Hands on, who have heard of map? Okay, let me explain this very shortly. We will use it later during the workshop, so you will see it again. If you don't get it now, you have a second chance later. What map does is you give it a function and it puts every value from an array through this function. So if I say map number, it just maps all the splitted array parts to number, which means we get an array back which are just numbers. So our parts are already numbers, and then all I have to do is I can sum these numbers together, and that's our result. Okay. Yeah, and it still works. Tests are green. So we can improve it a little bit more. First of all, we don't need these brackets anymore. We just have one line of code. And if I remove the brackets, I can also remove the return. Let's do it in 2 lines of code to get it more readable. We can say, if we have a string, we can split the string by comma, map it to number, and then get the sum of it. That's a little bit more expressive than what we had before. And now we can also improve the sum function, because there's a very simple function we can use instead of a loop, which is called reduce. What reduce does, who knows reduce? Who have heard of reduce? Okay, not so many. What reduce does, if you have an array with different elements in it, you want to reduce all these elements to one number. So a sum is one possibility, but it could also be the product of various number, or we concat all the numbers to one big string or whatever. You just would want to build one element out of several elements. And in this case, we could do something like, let's say, array of numbers. Let's reduce them, the numbers from this array. And what we need to give the reduce is a function to explain what to do with 2 different values. So we have the values a and b. And what we do is we just add them together. Reduce will do this for every 2 values in our array. So at the end, we get the sum of the whole array. And that's just it. We can do return, and we can remove this, and it still works. And we can remove the brackets and the return, and yeah, this is the result. Now we have a string calculator in like 4 lines of code, which is still very readable, or even better readable than before, if you're used to the new JavaScript elements, to the new syntax. It's something you need to get used to before you can actually find this more readable, I think. Okay, just as an example, back to the slides. Now it's your turn. Now you can try something out. Try TDD bin to do some TDD and some modern JavaScript. And the application to main, I think most of you will know it. It's the game Tic-Tac-Toe. Who haven't heard of Tic-Tac-Toe? Okay, yeah, you don't? Ask your neighbor. He can explain it. Okay, so we tried to write a Tic-Tac-Toe, and the idea is to have a function, something like who is the winner. You give them a field, and it either reports O or X. These are the 2 possibilities. One of these 2 has won, or if you give them a field where neither player has won yet, it just reports something like empty string or null or false or whatever you like to design your interface. Okay, now I need 4 volunteers. Some of you have put their JavaScript knowledge very high on the chart. Hopefully you're still here and you can help the other people a little bit. So I'm looking for 4 JavaScript wizards. Not all together. Some of you would like to help the others as a JavaScript wizard, have put their JavaScript knowledge pretty high up there. Please come forward. I need 4 of you. Otherwise, I will pick someone randomly. It's a great opportunity to learn something. You will see a lot of different code bases, can ask different questions, help the people who would like to volunteer. Okay, seems like I have to pick someone randomly. Really? No one wants to help me a little bit? Want to become a Java? Yeah, thank you very much. Come forward, come forward. I promise you don't. Hey, woo! Our first JavaScript wizard, yay! Okay, 3 more. Now you know how it works, yeah? Just standing up, going here. It's not so difficult. We don't need to know about all the new JavaScript stuff. Just have some JavaScript experience would help a lot. 3 more wizards.
Maybe just ask whoever wrote JavaScript.
Yeah, that's a good idea.
Live stream and see who puts the...
Yeah. Who puts these dots there? Wow. Seems like they've already left the room.
I can use the YouTube stream and rewind that. And
Good idea. Oh, another one. Yay! Woo! Big applause. Okay, I think that's enough. 3 people, we can cope with that. So everybody knows that you're really a wizard. I have one of these nice hats for you. And I will put one of them on myself. So, and we use some kind, oh yeah, that would also work. We use some kind of color coding. And there were, okay, maybe they're no longer there. You can imagine the room in 4 quadrants with different colors. Where have been the heads? They're there on the side. Yeah. Just keep it there. So this is your quadrant. You could help the people in this quarter of the room. And where's yellow? Somebody sees yellow? This must be at one of the walls there. Okay, perfectly. So please go to the wall at this part of the room so you can help the people around this area. And I will do the area there and there. So if you have any questions, just feel free to ask any of us wizards. Thank you. Okay, now is your part to find your pair. Find someone you would like to code with, and it should be someone you haven't coded before. So that means you have to switch places, probably. Find someone near you, left or right of you, who you would like to code with. One of you should have a notebook, and it should be one you haven't coded yet before.
It's not possible on paper.
It's not possible with pen and paper. Yeah, ask your neighbors who you would like to code with, find someone, find a place. I explain shortly. Just one moment. Yeah. So, if you are ready, go to TDDbin.com. There you find this working environment, and you can just start. Just use JavaScript, try to use test-driven development to write the tic-tac-toe game, okay? Write a solver. And the job of you wizards are just look around, look at the people, see what they're coding, and help them. Make suggestions, maybe have questions to you, so just look around at the code of the people and help them. There's another question, yes?
The result should be a whole tic-tac-toe game with the board, or just functions that are...
We start with just writing this function. Who's the winner? The function needs to get a board, and then it just should return the winner. But you can do it however you like, how to represent the board or how the algorithm works. It's just completely up to you. Okay. So, gibt's Sadly, the time is up. Who has finished? Okay, I didn't expect anyone to finish. That's okay. We just want to try it out, find some ideas, and what we do now is we have a short, we are here. We will have a short retrospective, and for this I want you to find a new partner, someone with you haven't coded just yet, so you get an idea what does the other one did different, what was their approach, what were the problems, what have you learned probably. So find someone you can discuss your solution with. So please. Sorry? Oh yeah, that would be a good idea. Just maybe, not the same number of people. Just find someone else, just like 2 places away from you, with whom you can discuss. Someone you haven't just coded in the last session. Okay, so please, you need to swap places for this. Find someone have a good discussion about your approach. Okay. So please stop coding. Stop coding yet. We just want to discuss how the session was. Oh, and also please delete your code. There's a reset button. Just press the reset button at your code. Oh, yeah. I'm not connected now. Just press the reset button on the TDD bin, and then have a discussion about how your code worked, how you liked it, how your approach went. Okay, discussion time is up. Discussion time is up. So please, I would like to invite you to share some of your findings. So, if somebody wants to tell us about something you find interesting, was new to you, you learned something, or how your approach worked, so just tell us and I will come to you and you can speak to the micro so that everybody can hear you. Who has some interesting findings? to share? Nobody? No interesting findings? There, back. Yes, Christian.
I think our approach was very dumb. We kind of checked hard-coded indices, and it worked for the first test cases. And when I looked around the other solutions, they often ended up building complex systems. Okay, sorry. You didn't hear me the whole time? Okay, let me start over again. We started with a very dumb implementation. We essentially checked hard-coded indices. That means we had a couple of if statements, nothing else, and then started coding the tests. They went red, and we implemented just a single case that worked. So we started with nobody wins, then the first line wins X, the first line wins O's, and then second row is just another if statement. So it has very dumb code, and we eventually refactored it, and we managed to make, I think it's 8 green tests. And when I looked around, many people started coding very complex systems that didn't fulfill a single test because they were very complex. And this approach helped us code very simple code. Has a very simple result.
Okay, thanks a lot. Yeah, very nice approach. Somebody else? Other impressions, ideas, something you learned, something you find out? Who wants to talk about it? Somebody has to share some ideas, or yeah?
Yeah, I find the test-driven development approach makes you think about refactoring your code really early in the process. It's nice to think about your code structure a lot more if you write tests first and then the code.
Cool. Thanks a lot. Any more findings, ideas? Yeah.
Unfortunately, I take the other side. For me, it was pretty difficult just to decide what is the first test. So I already failed at that point. And I don't know how to start.
There's no failure in this workshop, so just keep trying.
But it was pretty difficult just to make the decision, what is the first test? Yeah, I would be interested to how to make that decision. What is the test? Yeah.
Okay, so you expect an answer from me, yes? Now, I'm not sure if I have a good answer to you, because it's also the same feeling I get. To get the first test right, it's one of the most difficult decisions. So I don't think there's a general answer to this, but I usually start from somewhat simple. I'd like to reduce my problem and find the simplest case I can think about. Just like have a completely empty board, and in the case of a completely empty board, I return something like no winner. It's maybe a good idea to start, but it's different depending on the problem, of course. Okay, thank you all. We will continue with some more information about JavaScript and ECMAScript 6, and then we have another session where you can use this new knowledge about ECMAScript 6 and JavaScript in general works if you do it more like a more object-oriented approach. We will take a look at classes, how classes look in JavaScript, especially with the new ECMAScript 6 syntax. And here's the first example. If you have, I think that the title is wrong. Yes, that's from the other slide. Doesn't matter. If you take a look at this in ECMAScript 6, now you have the class keyword. You can just say I have a class person or something like that, and you can just say new person, like in most object-oriented languages you know, and then you get an object back which you can store like in a constant or a variable or whatever you like. And then there are constructors. I think it's quite similar to PHP actually. There is this function just called constructor, and you put something in there, and you can use it to assign it to a property like the first name, for example. And just let me show you. If I change the parameter and it's not Peter but Michael or whatever, then you get an object back with the key first name set to Michael. So they changed mostly the syntax. In the background, there's still just objects, which you may know from this angel brackets syntax. You get back there, but now you can code it as a class and have constructors and use this syntax that is very well known in most object-oriented languages, I think. What else can you do? You can use something like a getter. If you have a method like shorted name, which just puts something like Smith, P out, you can do it as a getter. If you write, I can show you, if you don't have this get, then it's a method. You have to call it with the brackets, and you get your value back, but you can use it like a property, but just putting get there in front. And this makes it very simple to keep the interface. You can start with simple objects that don't have these values just as attributes, and later on you decide, oh, there shouldn't be attributes anymore, there need be some processing there need be some behavior you want to have in methods, and then you can just switch out by writing a method and put a get before. And then you get rid of the attribute. So that's a pretty nice way to make transitions and keep a common interface. There's also the counter side of this with the setter. Let's say you have something like a person, Peter Smith, but you change the name and assign a new full name like Steve Wesson, and then you want the attributes, first name and last name set from this full name property. You can just declare full name as setter. And then even if it looks like this is an assignment, it isn't. It actually is a method call. It just looks like an assignment with equals, but in the background, what it does is it calls this method and does the behavior of this method, which is just it splits where it finds the space, and then it assigns the zeros and the first element just in first and last name. So you can just write anything as properties, even if it is behavior. That's the idea. Okay. So this is what the session is about. To make it a little bit more interesting, we like to try a constraint. We like to give ourselves a constraint which we don't want to do. And the constraint we want to have is no primitives. What does no primitives mean? What we did before was we inserting simple values like numbers, strings, or maybe an array to represent a board in tic-tac-toe. The idea is, if we have something like a person class, we don't want to work with the values like forename and age and city and zip and so on, which are just strings and integers. We want these to be classes themselves. So we want to have something like an age class or a name class or a place class, and this encapsulates the primitive values. The idea is to get a real object-oriented approach. We want to not use primitives at all. We just want to work with objects and classes. And there's just one problem, or first rule, of course, wrap all primitive values. You don't want to have to use integers directly or use arrays or something directly. And this also means you're not allowed to use primitives as parameters. Like the function we had before, most people just put an array in there. This is not allowed in the next session. You need to have like a class for this, like a board class or something, which represents your tic-tac-toe board. This is something you could use as a parameter, but not the primitive objects, not the primitive values like array or integer or string or something like that. The problem is, we somehow have to start with. Therefore, if you do a constructor, you can put primitive values in there. Otherwise, you put objects and objects and objects and objects, and somewhere you have to start with the primitive value. So for constructor, it's okay to use a primitive value. For every other method, for every other function, primitive values are not allowed. And you also should not use unbound functions, means simple functions, just only use methods. Like, you can go back. Like these. Actually, I think I don't have even an example for a simple method. Wait. We have now. This is just a method. Shorted name is a method now, because it's bound to the class or to the objects of this class. And you can call it from the object with dot method name. You can also use getters and setters if you like. It's not necessarily needed, but you can, of course. Yeah, and that's basically it. So find a pairing partner and try to solve the tic-tac-toe problem, but now use classes for that. Don't use primitives anymore. Try it. Okay, go on. Starts now. I will leave an example up here. And we also have some handouts, so you can take a look at the syntax, so you don't have to memorize everything. Möchtest du vielleicht beim Austeilen ein bisschen unterstützen? Oder?
Ja, kann ich machen.
Cool. Genau. Schon? Ja, ich kann ja die. Einfach durchgeben. Ist es für euch okay, noch eine Session zu supporten? Oder war das in Ordnung? Ja. Okay, cool. Ja, man sieht halt auch einfach mal sehr viel unterschiedlichen Code und kriegt mal so eine Idee. Sorry, time's up again. Hopefully you had some interesting experience with classes. And I would like to do the retro just without the discussion before, since we run a bit late in time. So just asking, how was the experience? How did the approach with Classes work? Do you like Classes? Was it difficult? Did it help somewhere perhaps? So what's your opinion? Just who has an opinion on this? Okay. Who liked Classes? It would be maybe hands up who liked it. Okay. Who disliked it? Okay, nobody disliked it. Interesting. Very interesting. So, and what was your? Somebody wants to say something about it. What worked great? What was difficult? Yeah, oh, Wizard, thank you.
Hi. I had the feeling that by using classes, people just are more able to abstract the problem to get a solution. And without using classes, they really stick into the board and making X's and O's. So this is different I felt working around. So they tried and they have been more able to abstract everything.
Okay, thank you. Very interesting. Any more insights? Yes.
I like working with classes, but I'm not very familiar with working with classes.
Sorry, does the microphone works actually? Okay.
Now?
Yeah,
better.
thank you.
I like working with classes, I really do, but with JavaScript, I'm not working a lot with JavaScript, and I think once worked with classes, or I tried to do this, and so it's a little bit weird to use classes with JavaScript, and that was the problem by solving this problem. It wasn't about thinking what to do or how to do it, only the technique behind it.
Mm-hmm. Interesting. Somebody else have an opinion on this? Okay, then we just go to the third and last session. And the last session is about arrow functions. You have seen them before when I used them for the string calculator cutter. Now we will go a little bit more deep into this. This is how arrow functions looks like. We have this arrow to define a function, and we have the square brackets with the function body behind it, so it's not so much different from normal functions you're used to from ECMAScript 6. ECMAScript 5, sorry. The big advantage is you have a more dense syntax. You can even leave out a return if you want to do something really simple. Now we have a multiply function, and we get just a and b, and we want to return a, the product of a and b. That's very simple. It's just an example. Not much sense in doing this, but it's interesting if you combine this with other features, because you have seen this this map function before, and let's say I have a function double, which doubles any value I put in there, and I can also leave out the parameters, the parentheses around the parameter. I don't even need the parentheses if it's only one parameter. And now we want to use such a function like double, or in this case it's the square. We want to use such a function on a whole array. In this case, you can put it as a parameter inside the map function. Okay, in this example, we have an array with 1, 2, 3, and 4, and we map over this array. And if we had used ECMAScript 5, we would have written something like function, which gets a value, and then we need brackets, and then we need to return the value multiplied with the same value. This works, but the combination of this original function syntax with map is a little bit hard to use, hard to read. Therefore, the arrow functions are very useful because we can now just say we get an we in for value and we return. We don't even need the return keyword. We just return the product of we and we. And that's just it. And now we get a result where each element is put through because map is applied to apply this function to all elements, and then we get the results for all elements, and we can put any element in there we like, and yeah, it just works. We don't need a loop anymore. Very similar is the function called filter. Filter also takes any function, like for example the function even. Even just looks like if you can divide a number by 2 without any rest. So if the result of divide by 2 is 0, the rest is 0. This is the modulo operator. You might know it. And then a number is even. And if we filter by this function by even, we only get the even numbers as a result down there. If I put any number in there, let's say 8 is there, but 9 isn't, it gets filtered away. This is like a combination of a loop with an if to drop some values, and it's much more readable to write a whole loop with all the logic in it. But we need these arrow functions to make it very expressive. Okay, and now I show you what you've seen at the beginning at the string calculator cutter. There's also the reduce function, and with the reduce function, we reduce any number of values from an array to just one value, and you can describe how this reduction is done. If you say it's a plus, then you write a sum function. But you could use any function there, like let's say multiply them or whatever, and then you get the result of a multiplication of all these values. So it's very general approach. There is some tests. If there are some value in this array that fulfills the requirement, are there some values that are even? Yes, some of these values are even, so the result is true. Or I could use every test if every element from the array fulfills the requirement. So is every of this element is even. Only if every element is even, I get a true, but there are some wrong values, so I get a false. There's a question?
Is some just giving true if one is even, or?
One or more. One or more. One or more. Wait. One is enough, so if I just only have like the 2 in there, if I have only 1, it's false. There's no even number in there, but if I put, let's say, a 4 in it, then it's already true, and I could have more even numbers, and it stays true. So 1 or more even numbers, and then some of them are true, at least 1. Okay. Yeah. That's about the arrow functions, and now comes the advertisement block. If you like this workshop, I have also written 2 books about it, where you can read the stuff up. In the first book, there's a big chapter about arrow functions and map and sum and every and all this stuff. So if you're interested in this, yes?
It's only in German?
Oh, yes, sorry, it's only in German, yes. There are 2 German books. We are planning a translation, but it's not available yet. So, yeah. So if you're interested, just look them up. If you type something like JavaScript at Amazon, you will find it. It's like on the first 3 results or something like that. Okay. Back to the arrow functions. We will now do a sessions with the arrow functions. It's the last session for today, and the requirement is very easy. Don't use any loops. You don't need them. You can use functions like map and filter and reduce and every and sum. You don't need for loops anymore. You can just do it with high order functions, and yeah, that's basically it. So try it. I have also some additional handouts. And yeah, it's the same task. We want to have this tic-tac-toe running. Yeah, any more questions? No.
Setting a property that you only getter.
Handouts? Any more handouts needed somewhere? Okay. Okay. Time is over again. So first of all, I would like to thank our wizards for helping us out here. So a big applause to our two wizards. Thanks a lot. We will do another retrospective, and this time we will do it a little bit differently. So just take a minute or two for yourself to think about just one question. What did you learn today in this workshop? It could be in the first or second session or the last one. Just think about what is the new things that you learned about, that you like, that you probably take to production. The question is just, what have you learned today? Just take yourself a minute, think about it, and then we will take some opinions. You could also write it down if this helps. Okay. Yes. Is my micro on? Yes. Okay. Now we will take some opinions, some answer to this question. So what have you learned today? Who wants to share what he has learned today? What was interesting for you? Yeah, our wizard. Hey.
A special thing, I'm using the Lodash library often, and for me it's new. I can replace some functions from that. I used like map and reduce, so I don't need to use Lodash for that anymore.
Oh, that's great. Do it with the native JavaScript. Anything else? What have you learned today? Who wants to share? You've learned nothing today. Whoa, wow, my workshop wasn't so great, I think. Anybody has learned anything new today? Nothing? Ah, there.
Yeah, what I really liked was the class mechanism that is now available in JavaScript. I really missed that a lot in the past, and I'm really happy that you can use the class syntax now in JavaScript. So thank you.
Okay, great. Anything else you have learned? Maybe something about test-driven development. Ah, there, in the back.
Okay. We got along very well with the first approach. We got quite far with it. And with the second approach with objects, we really had trouble getting our head around building with so many objects. So a simple function, who is a winner? Building the whole game, tic-tac-toe with objects would have been fine. But this simple function, it was just overcomplicated that way, and the approach, this test-driven approach, didn't really work out for it in that time. So starting a simple thing and in a very naive way, in this simple example, worked out way better than the object-oriented approach for me.
Okay, thank you, yeah. Also very interesting learning. Sometimes objects are just overkill, maybe. Okay. Anybody still wants to share something? If not, we are through with the workshop. So, shameless plug again. And yeah, we're at the end of the workshop. I hope you had some fun and learned something new about JavaScript, about a modern way of doing JavaScript. And yeah, enjoy your JavaScript. I will be available for some more hours. I think there's a coding night now. If you have questions, feel free to come to me, ask, or maybe we can code something together. So thank you for being here.